Hello everyone. So today we're going to try and find the volume of a regular tetrahedron with side length A. So this is a Calc 1 question. And when you're looking at volumes in Calc 1, you'll see volume by slicing, volume by rotations, disks and washers, shells. We're not going to be looking at those last three things that I mentioned. We're going to be looking at slicing. And the idea with slicing is that you take your solid and you're going to slice it up, like cut it into pieces. And you can cut these pieces any which way you like. Now, with my drawing here, I have these like red triangles, and those red triangles are equilateral triangles. And the big idea here is if you find the area of those equilateral triangles and add them up together, that gives you the volume. That's the whole idea behind volume by slicing in so many words. And let me just go through the principle here. If A of x describes the area of a cross-section along an axis, say x, and the x here does not have anything to do with the x-axis that we know necessarily, I'm just using that variable by default, and these cross-sections are perpendicular to the x-axis, then the volume is equal to the integral from a to b of a of x dx. And what I'm trying to get at here is I'm going to make a formula that describes the area of these cross-sections. And the area of these cross sections is going to be basically based on the area of an equilateral triangle. Okay. Now, in order for me to solve this integral, first of all, I actually need to find the total height of this tetrahedron, because I am going to be doing slicing along a vertical axis, basically up and down here. And this goes back to the fact that all these slices are perpendicular to this height right here, okay? And I want to go ahead and figure out what that height is. And here's how we're going to do that. We're going to draw the center of the triangle, we'll call the orthocenter, put it that way. And we're going to draw a right triangle. From there to the center to one of the vertices, call this B, and yeah, and H, that would be your height, and then you have a right triangle there, and you have that A squared equals the height squared plus B squared. That side length B, I'm going to go to the blue triangle here, is the distance from the center as to the vertices, and that distance is the same for all sides here. I didn't draw that all that great here, apologize, but that length B is the same. And we know that these triangles, by looking at them, and it's not automatic, but it takes a minute, but you'll see it. It's all the angles inside are 120 degrees. And what I want to do with this is get an expression for B. Because if you go back to the equation that I set up, a squared equals h squared plus b squared, I have two unknowns. As I said, I really want to get the height, but that b, I don't know. And again, a is a fixed constant. So perhaps I can build a relation between a and b, and that's what this triangle does. A couple ways of doing this. You can use the law of cosines here, but what I'm going to do is as follows. I'm going to draw a altitude from that orthocenter to this side. And this length would be a over 2, and furthermore this is 60 degrees and this is 30. If you were to take the cosine of 30 degrees, that would be a over 2 over b, or b cosine 30 equals a over 2, and the cosine of 30 degrees is root 3 over 2, so I'm going to replace that there. So if you solve for b, b would equal a over root 3. So I'll let you pause and take a look at that. And if we were to take a squared equals b squared, which is a squared over 3 plus h squared from that formula that I wrote a second ago, which was up here. Yeah, just replace the the b with the a root 3. You would have that h equals root 2/3 a, okay? And that would be my height total, okay? And yeah, we're gonna use that eventually here when we set up an integral. Now, that's great, but we have to, so yeah, it's a long video here because we had to derive the height, and we have to derive the area of the cross sections, and these cross sections being equilateral triangles. So let me go ahead and draw that again over here. So this would be length S. So I'm drawing this generic equilateral triangle that's a height x units away from the center. And what I'd like to do is find an expression for S, okay? And yeah, you see it written here. Let me actually just erase it, so, because maybe we're giving too much information away for right now. And here's what I'm gonna do. I'm gonna take the face of one of the faces of the tetrahedrons, which is A, and then I'm gonna take, so let me just highlight that here in orange. And then let me highlight in green now, or yeah, this color, that triangle. That triangle would have length S here, okay? Because it's an equilateral triangle as well. And these two triangles are similar. They both have angles of 60 degrees all inside, so they're similar triangles. They're not congruent, but they're similar. And we're going to use one more fact here, which is that if you take the height of the, sorry, not the height, but the height for which the triangle with side length S is from the bottom, which is like x units, this would be, this whole thing is h, so this right here would be h minus x. H minus x all over the height of the original, well, not the tetrahedron, would be h. That has to be equal to the ratio of the length of the side S over the side A of the triangle we're working with. There is, yeah, so this is a consequence of similar triangles and what we call transitivity. But in general, if you have two triangles that are similar, then the heights at which they're at from the bottom have the similar ratio in terms of proportions. They're equal, okay? So that's just a fact that I'm using. And I'm not going to go into more details on how I got that, just because, yeah, it'll take a while here for us to derive. So h minus x over h equals s over a. So s equals a times h minus x over h, which if you did the math, this would be a minus x over root 2/3, okay? I didn't replace h with root 2/3a. It is equal to that, just recall. But because it's kind of a messy term to be working with, I'm working with what you see here. So that's the length of any side of any triangle that I slice up vertically, okay? Now, so once you get that, you're pretty much good with these problems, because the next part often entails you using an area from geometry. And a of x here is what I'm looking for, and that's the area of the cross section, which is an equilateral triangle, which is equal to root 3 over 4 times the side square. So this would be root 3 over 4 times that length of that side, all squared. And all you'll do is integrate that from 0, from the very bottom, all the way up to root 2/3a, okay? The integration, I'm not going to get into that. It's a u substitution. And at the end of the day, you get what you see right there. And there we go. So this is one of the more difficult problems out there. I just wanted to go over an overview of that because it's a very popular problem as well in a lot of calc books. And yeah, definitely take some time. So I thank you for your time and for your patience with this, and I hope this helps. Thank you very much.